This is Cleanroom from StricklySoft, production changes without production risk. Teams change two things against production: application code and database objects. Both are risky. Developers need production-shaped data to build and test, but you can't put production data on a workstation, and you can't let everyone touch production. The hard part is meeting both of those needs safely and the same way for every change. Cleanroom gives every change one safe loop. Whether it's an application change or a database change, it follows the same path. Work locally against safe, production-shaped data, then a code review, then a gated deploy to production. Nobody works in production. No laptop ever holds production data or a production credential. It's built on the tools we already use: Azure DevOps for repositories, work items, and pipelines, and 3 data tiers: Azure SQL as production, strictly read-only, a platform-only Azure Dev Server that holds a tokenized copy of it, and disposable local dev environments built from that dev server where the work actually happens. One workflow governs both application and database change. So where does safe data come from? That platform-only dev server holds a tokenized copy of every production database, the real schema, the real shape, and none of the real data. No human ever connects to it. It refreshes from production on a schedule. From it, the platform builds each developer a disposable local environment on demand. One click, nothing to import, and nothing to set up. Production data never leaves the platform. Every change begins as a ticket in Azure boards, a bug to fix, or a feature to build in the application or the database. This is the same queue the developer sees without ever leaving their editor. And where do those tickets come from? The help desk, a clean front door for the support team on the same Azure DevOps. Someone reports an issue, attaches a screenshot, and it becomes an Azure Boards work item the developers see instantly. It also has a built-in knowledge base of common issues and fixes, so a lot of problems are solved before they ever become a ticket. And that knowledge base isn't a new system to run. It's the Azure DevOps wiki, the same Azure tooling we already use. The code lives in gated repositories: the application, the database projects, and the data access layer. Every one of them requires a pull request, a reviewer, a linked work item, and passing checks before anything reaches the main branch. Application code and database code are governed exactly the same way. Those checks run in Azure pipelines: build, tests, and a required code review, and, for database changes, a block-on data loss check that stops a risky change before it can ever be published. Here's a database change. Open a ticket, and Cleanroom spins up a local dev environment for that ticket and its branch. One click. You work in normal SQL against production-shaped data. When you publish, your change goes up to the Azure Dev Server and queues a code review ticket. Nothing has touched production. Now the reviewer. The code review ticket spins them up their own fresh local environment, built from the dev server with your change already applied, so they run it and test it, not just read a diff. They approve and submit, and it flows to the gate and merges to production if it passes. If it fails, the ticket comes back to you with feedback, and the loop starts over. The reviewer can never edit the change. They're a gate, never a second author. A closed loop with separation of duties enforced by the tooling. Application changes follow the very same loop. Developers build against the same safe dev data through the data access layer: local, then review, then a gated deploy. The application uses dev data in development and production data in production, and it never holds a credential. That data access layer is the key change. Today, data access typically lives in a library, a DLL, compiled into each application, so every app opens its own connection to the database, wherever those credentials happen to live. A change to it has to be rebuilt and redeployed to every app. The stronger model, the data access layer becomes a hardened service, one audited wall in front of the database, centralized, hardened, and audited in a single place. Applications call that wall over a scoped token, so no application ever holds a database credential. It's centrally hardened, every query parameterized, no schema changes, injection blocked. It's centrally audited, every query logged, and it can be rotated instantly in one place. Best of all, it routes by token. A dev token reaches dev data, a production token reaches production. A developer's machine only ever holds a dev token, so it physically cannot reach production. And adopting it is a single, small change. The existing library stays right where it is. It just becomes a thin client that calls the service instead of opening the database itself. The application code doesn't change at all. The library simply swaps a direct database connection for one authenticated call to the wall, one change, and every application is instantly behind the audited wall. And the wall enforces the rules. Every query is parameterized, so input can never alter a statement. Only whitelisted databases are reachable. Schema changes and multi-statement attacks are rejected outright. Every call is routed and scoped by its token, and every single call is written to an append-only audit trail. Underneath, the database is not on the internet. The Azure SQL firewall allows only a short, explicit list of addresses, the data access layer, and a named admin address for maintenance. Everything else is denied. There's no public door, so a stray connection string reaches nothing. The wall is the only door, except when it can't be. Some maintenance the wall simply can't do. Patching, index work, provisioning. For that, a database administrator gets just-in-time, time-limited, fully audited direct access, sealed, logged, and exceptional. It's the rare exception, never the everyday path. Every credential and token is issued from a secrets vault, encrypted, access-controlled, and scoped to exactly what a caller needs. Nothing sensitive is ever committed to a repository, written to a log, or left in a file a developer or an auditor could read, and a token can be rotated in one place. This is defense in depth. Developer services bind only to the local machine. Connections use TLS with no certificate shortcuts. Containers run as a non-root user. Responses carry hardened security headers, and authentication fails closed. Security isn't a feature we added. It's the floor every line of code is written to. For the developer, all of this lives inside Visual Studio Code. The Cleanroom panel shows the open work, tickets straight from Azure boards, with who owns each one. Opening a ticket and clicking, Start builds an isolated tokenized dev environment for that ticket and its branch, in seconds. And there's no separate panel to learn. The dev server lives right in the SQL Server tab. One button builds or rebuilds it. Every production database under its real name with tokenized data, no manual setup and no connection strings to paste. When you start a ticket, it drops you straight onto that tab, on the connection for your change, ready to work in normal SQL. So, from a ticket to a local fix, through review, through the gates, and out to production, one continuous, auditable path for application and database change alike. And at no point does real production data or a production credential ever touch a developer's machine. Application and database development on one governed platform. Production-shaped data everywhere, production data nowhere it shouldn't be. Every change reviewed by a second person and deployed through gates. One audited wall to production with break glass sealed and logged. That's Cleanroom. Production changes without production risk. From StricklySoft.